In stats, we continued with this handout over density curves and the bell curve. To start out, we drew a bell curve here. And this asks us to label 3 standard deviations out from the mean. So to start out, let's draw a vertical line right down the middle, and that'll resemble our mean. Now we're talking about the population. Notice up here, population mean. So this isn't based on a sample. This is every single test score divided by the grand total. So that means we use the Greek letter mu, and notice down here, this is the population standard deviation. We're using the Greek letter sigma. So notation is important. While I don't necessarily grade how well you do it, drawing the character, it is important to be able to distinguish between samples and populations. So what you do here is you make vertical lines, dividing it up so we can resemble 3 standard deviations to the right, and try and make those vertical lines about symmetric on the other side. It won't be perfect because you're drawing it by hand, but give it your best shot. So I know that standard deviation in this case is 1.55. So what I need to do on my calculator is add 1.55 to 6.84. So I'm typing 6.84 plus 1.55 and I get 8.39. I add it again and I get 9.94. I add it again and I get 1149. I need to now subtract. So 6.84 minus 1.55 gives me 5.29. 3.74 and 2.19. I like to label it above the line with how many standard deviations we're referring to. So there is our sketch of the distribution of test scores. Now we're going to refer to this here in a second. Let's talk about the empirical rule. So the empirical rule, this is something true. This is what Gauss derived whenever he figured out that this bell curve existed. And he discovered that approximately 68% of the distribution falls within 1 standard deviation. Approximately 95% of the distribution falls within 2 standard deviations. And the last one, approximately 99.7% of the distribution falls within 3 standard deviations. Now, one thing to consider whenever we start looking at these questions you see down here is this bell curve is perfectly symmetric, but it's not necessarily proportional if you divide more than 1, 2, or 3 standard deviations. In other words, let's look at the graph I just drew. I know, now I wouldn't mark on your paper. We're going to mark on it in a second. But I know that according to that rule, 68% falls in that range right there. That means, because it's symmetric, 34% is right here. That also, well, first back to the rule. This is 95%, which means half of that is 47.5%. All right? So sometimes you got to be clever with how you shade the areas and you apply the rule that we just looked at. So we're going to use that rule to answer the following questions. And there's a bunch down here. I'm going to scroll down and then I'm going to go back to the graph. So if you want to see all these questions, they're going to disappear here in a second because I need a graph to go off of. So I'm going to scroll down. Here are all the questions we're about to answer. And I'm going to jump back to the graph that we had. So if you need to write those down, that they're printed on the handout. That's what I'm looking at when I answer these questions. So for that first question, I'm going to change the color and this screen is going to get very busy. So for that first question you see, it asks percent of scores less than 374. So I write this like this to start out. And I like to shade, or at least mentally shade. You don't want to mess up your graph because this will get really busy here in a minute when we have multiple questions. But I'm looking at that space right there. So think of it as a portion. What portion of that curve has been shaded? That empirical rule tells you that this portion is 95%. So if I take away that middle 2 standard deviations, I just took 95% away from the distribution, which means we have 5% outside. So there's some over here right now. But I only want that left tail, so chop 5% in half, and you have an answer. So the way to mathematically do it, take away the middle 95 and chop it in half to get that tail. So 2.5%. Approximately. It's not exact. So we have another question. What percent are between 529 and 994? Got to be really clever on this one because it's not a set standard deviation. It's referring to 2 standard deviations, 2 different ones, I should say. So we need to get rid of this red. Whoops, that didn't look good. Let's get rid of this red. Sorry, I won't be able to clean it completely away. And let's shade where we're talking about. So we are looking at here to here. And this is a lot like a composite figure that you looked at back in geometry when you took geometry. When you had all those rectangles put together and you had to piece the areas together. So we have one area here that is findable. The purple. And then we have the red. So we can get the purple because that's referring to 1 standard deviation and chop 68 in half. The red is referring to 2 standard deviations, so chop 95 in half, and we get 0.815, 81.5%. All right? All right, this is going to get really messy up here. So I think the rest are actually very doable. They're not as complicated as that one. On the next question, it says what percent or proportion is equal to 529? and that's 0. While yes, it's possible to get 529, you need to think of it as I need a width to it. This is more of a geometric question than asking for a likelihood of one single value. Like 528,9999 up to 529,0001, that has width to it. That is way different than 0. So if they ever ask an equality question, what's the proportion of values that equal a continuous value? It's just 0, because there's no width to it. So you got to think of it geometrically, kind of like a rectangle, length times width, and there's no width to that. So if they change it and they ask for 529 to 839, that one's an easy question, right? That's referring to within one standard deviation. That's about 68. If they ask for the same question but throw in an or equals, it's going to be the exact same answer. And that is because equaling 529 or looking at 529,00001, it's an insignificant difference, so it's still 68%. This is all an approximation. So including a value or not has no bearing on the answer because this is continuous. This will be a whole other story if we start looking at discrete values, where like if there was a score of 1, 2, 3, 4, or 5. That'd be a whole other story. Let's see, we had a couple more questions. We had, what's the proportion of values less than 529? Let's see, I still have some space to shade there. Look at the green space. So that's left of one standard deviation. So mathematically, let's do 1 minus 68. And I want just that left tail, so divide by 2. And we get 16. We had one more question. What proportion is less than 374? Or, I'm running out of room. Proportion greater than 994. So that's asking for, I guess I could shade it. It's getting really crowded on here. Let's use black. So I'm going to shade where this last question is asking. So left of 374 and right of 994. And that's a pretty easy one, right? Because I know in between those two marks is 95, so it's just 1 minus 95. So that is 5%. All right, I hope that made sense. That is almost the end of the handout, but that's a good stopping point for now. Talk to y'all later. Bye.